For this project, I'm using Blender 2.82. The most current version is Blender 2.82a. It should work. Pretty much the only thing that depends on the version is this plugin from XSEDE Blender and the ability to import models that are OBJ files. So any version, as long as those two things work, and we'll also download XSEDE, this program for annotating the layout of the scene to get the X, Y, and Z axis easily, and to import everything into the Blender file. So then you also have to install this Blender plugin. Right under this, it tells you how to install the plugin so that we can import these XSEDE files into the Blender scene. Then we will open XSEDE, and we can drag in a picture to open as a new project. And I chose this picture of a table because it was decent sized, and the resolution is about 1300 by 1000. And the output resolution of the rendering process is going to be the exact same as this picture. And then to use XSEDE, simply have to just drag these lines to line up with the different axes in the scene. So we can just use the outside of this table, and then this XYZ axis is going to be accurate for this table. So we can add a plane and place things on top of it. Once it's all set up, you have to File, Save As, and then we need to save it in the input folder with the same name as the photo. And it has to be either a JPEG or PNG for the photo, and this will save as a .xsede file. So we're done with XSEDE, and we can open Blender. And then just making a new scene, you can delete the camera and the cube. And we can go into scripting mode, and here we click on Open to open a scripting file. Go into the main folder and open scenesetup.py, and then we change the scene name to the name of the photo, and then this will also require you to change the path of the entire project folder, which contains all the scripts and the models and the inputs, and that's all you need to edit for this one. And then run it once, and then it will set up this scene with the background as the photo, and then it will add this plane that will act as a shadow catcher for the rendering process. So we need to stretch this plane to match the size of the table, and since XSEDE was able to take out the manual editing of the focal length and the camera and the background and everything, all we have to do is grab this plane with G, and then we can move it along the x-axis by pressing Y, or X, and then move it along the y-axis and put it about in the middle, and then use S to scale it up to the size that will be the render, and then you can scale it in the Y direction also. So this is going to be the surface that it renders on top of, and this won't render in the final process. It will see that this the background isn't set during this process. It's set during the main rendering process, but this plane doesn't show up in the render because it only catches shadows. And this is where it would also set up the lights. There's just one light in this scene, and it's right above the table, so you can move it around with G and rotate it with R to change its orientation, and also down in the object properties for the lighting. And down in the lighting panel, which has the light bulb, it can be changed between different point lights, sun lights, spotlights, area lights. Sun lights are usually better for scenes that have a lot of natural lighting, and point lights are better for scenes like this where it's there's not that much natural lighting, and there's just a chandelier on top of this, so it's pointing straight down, and that should be somewhat decent for rendering on this table here. So once the plane is set in the right area and the light is set up, or there might be multiple lights, then we just save this as a blend file. And again, it has to be the same name as the picture and the FSPI file, so that's able to be automated later on. And we save that in the input folder. So now we have the table 1 blend, FSPI, and JPEG file. The first time that this project is used, the paths for the two different files, the main program file and the scene setup file that we just used, you need to change the root path to the project folder and also the path to the Blender executable so that it can be run in the background on the command line. So these are the only two that need to be modified. The main program file doesn't need to be modified for every iteration when you run this program, but the scene setup needs to be run every time that the import process is done, and that only needs to be done once for the entire scene. All the different models that are eligible to use for this project, they'll be in the models folder, and we use the name of the folder to import the individual files. And it requires that inside of the model, it'll have this textured meshes folder with the OBJ of the TSDF texture mapped mesh with the PNG, and it'll automatically import both of those and move it around to place on the plane and render it. And running the program, we can just run the main.py, and then it'll go through all of the different scenes in the input, all the different blend files, and it'll ask for a model name and a number for the number of frames to render with different random positions. So I'm going to skip all of these except for the table 1 that we just created. So the model name doesn't matter, and if you put 0 locations, then it won't do anything. Same with this one. And then for the table, we can say generate, we'll use this model name. And to generate, we will use 25 different random locations. So we can see in the input folder for table 1, it's going to generate all these different JSON files. I'll cancel that real quick. And then we can see that in all of these files, it's going to have the X position, Y position, the name of the model that it's going to be rendering, and the name of the scene. So then right after all of these are generated, including all of the other ones that you put in, then it will render from each individual JSON file and be put in an output folder. The output folder doesn't need to be made right now. It will be created once the program is run. So I'm going to run this really quick with not generating any more locations so that it'll start rendering the 25 different JSON files that we had. And these are not deleted after an iteration in case there needs to be like a small alteration to each one, so you can edit it and save it. And then once this program runs, it'll take all of these ones that are generated from past runs as well to create the output files. And see, it rendered one of them already, so it'll output to a folder with the same name as the scene. And then in that folder is going to be the object rendered into the scene with a shadow and the mask also. And that's going to keep happening for every JSON file. So if these are decent quality, then the JSON file should be deleted so that it doesn't waste time rendering the exact same thing again. So I will wait until all of these are done and show the final output. Now that all 25 files are used to render, we have 50 files, one for the picture and one for the mask. And we can see if we sort by size, it'll separate all of them. and it'll generate the item all different places around on top of the plane that we created. And it also will only render inside of the camera boundaries. So if it was a different scene and it was a big plane like this, then it would only render in this central part of the plane. So it won't render outside of the render area, not to waste any time and generate some useless files. And the way the main program works is it looks through all of the scenes that end with a .blend, and then it will run the generate points file for each of these scenes, and will ask the user inside of this file to enter the model name and the number of locations, and then it will generate random locations on top of the plane, check if they're inside of the camera boundaries, and if not, it'll regenerate the point. And then it will save that to a JSON file in the input folder to run the rendering process. And then after that is done generating the points, it will go through all of the JSON files inside of the input folder and then add them to a list, and then go through that list running each JSON file with this render.py file. And this is how it saves each file. It takes the input JSON and renders the image and the mask, and it depends on how many files and the render resolution to see how long it'll take and how many images there will be. And then there's configuration options in here. This will scale the object to a factor of 8. The rotation won't be set to 0. So it's going to be facing the same direction every time unless the rotation here is changed. Also, the vertical offset, if it's a negative value, it's going to go lower down on the z-axis, or a positive value will go up on the z-axis. And this is kind of necessary because some of these models have some weird artifacting on the bottom. So if we lower it down, then it won't catch all those weird little pieces of it. And that depends on which model it is. And each one, it might have different offset properties that need to be changed, but I'm not sure. And then it will, since these are all run with the subprocess module, we can extract the information from the arguments. And because these two files, the generate points and the render, are they're run using the Blender executable, it'll show up in this folder. So I'm not able to do like a global configuration. It has to extract those details from it. And then the whole process is not too complicated. It's really similar to the Summer project. It'll import the model, and it will set the texture and change the node tree so that it has the correct texture, has the correct shape and color and whatnot. And then setting the background is doing the same thing with the compositor, and it'll change the world output so that the background of the render is going to be the background picture and not just a blank screen. And then setting the mask on the model, it'll set the model to have a mask of 1 so that it's able to extract the mask from the second image. And then running this, it loads the info from the JSON file and then imports the model, moves the model to the right position, and then we'll set the background, set the mask, set up the compositor, and then render the file. And this is what happens for each output. So the important configurations here are these object properties here, which will affect how the object is loaded into the scene. So using these config properties, changing any necessary config options in the main pie, the scene setup, and the render, then it's able to render any number of outputs given any input. And once the input is set up with the blend file and the lighting and plane are set up, then these can be reused over and over to generate any number of different outputs. And to make sure that these are all inside of the camera boundaries, then it will import a basic sphere and then check that each different vertex is inside of the camera's boundaries. So that makes it limited to the plane, and so that it stays inside of the camera views. And by default, FSPY will import the scene, so that going to this render properties panel, or sorry, the output properties panel right under it, since this image is 1306 by 979, that's the resolution that it's going to render at. But if we wanted to make it render faster or lower resolution images, then we can take down the percentage and see if I save this and then run the program, then we can see that the output resolution is very small compared to these other ones. And this is sorted by size, so these are all the first ones, and these are the following ones.